let t of x comma y equal to x plus y comma 2x minus 3y. We must show that the given function is linear. Show that t is linear. So here, if we want to show that the given function is linear, we must know that the definition of linear. So here definition of linear is that u and v be two vectors and c is scalar. Then we can write t of u plus v equal to t of u plus t of v. Vector addition must satisfy vector addition. Then t of c into u equal to c times t of u, scalar multiplication. So here left hand side in the question x and y is given. We must consider the two elements while considering u and v. So u and v are vectors. Let we consider u as x1 comma y1. So here we have two elements. We are considering x1 and y1. V is x2 comma y2. And here according to the definition u plus v is there. So here we add these two. We can add first element with the first element, that is x1 plus x2. Then we can add y1 plus y2. Now this one should be substituted in the given function, that is t of u plus v. T of u plus v is nothing but t of x1 plus x2 comma y1 plus y2. So we have the question t of x comma y equal to x plus y comma 2x minus 3y is there. So we substitute this as x. x1 plus x2 is x, y1 plus y2 is y. So here if we substitute here, instead of this x we must write it as x1 plus x2 and plus y is there plus y1 plus y2 comma here 2x minus 3y is there. 2 into x is nothing but x1 plus x2 minus 3 into y1 plus y2. So here we should not write function t. Why? Because we are substituting in the given function t of x comma y in the right hand side. So here we separate the element x1 y1 separately and x2 y2 separately. So here we can write it this as x1 plus y1 plus x2 plus y2 from this one comma 2 times x1 minus 3 times y1 plus 2 times x2 minus 3 times y2. Now we write it this as x1 plus y1 comma these two we write it separately, 2x1 minus 3 times y1, and we can write plus in between. Here x2 plus y2 is there, x2 plus y2 comma 2 times x2 minus 3 times y2. So here let us consider this is equation number 1, and now we find out t of u. So what is t of u? So here x1 and y1 we must substitute in the question. So question is x plus y, so x is x1 plus y1 comma 2x is 2x1 minus 3y1. Similarly t of v can be written as v is x2 comma y2 is there, so here x2 plus y2 comma 2x2 minus 3 times y2. So here this one is equation number 2. So here we can see that the first half of the term in the equation number 1 is nothing but t of u, and the second half of the term is nothing but t of v. So here vector addition satisfies. So we can see that t of u plus v equal to t of u plus t of v. So here vector addition is satisfied. Now let us consider the scalar multiplication. So t of, so question is t of x comma y is x plus y comma 2x minus 3y. So here t of c times u. So u is x1 comma y1. So if we multiply, we can write it as c x1 comma c times y1. Now this one we substitute in the given function. X is nothing but c times x1 plus y is c times y1 comma 2 times x is c x1 minus 3 times y is c y2. Here we can see that each and every element is multiple with c. We can take c as common. We can write it as x1 plus y1 comma 2 times x1 minus 3 times y2. So here already, sorry, y1. Already we have seen that this is nothing but u, c times t of u. So we have t of c into u is nothing but c times t of u. This is equation number 3. This is nothing but scalar multiplication. Is satisfied. That multiplication is satisfied. Hence t is linear.